Welcome back. We're on problem number 13. And I started problem number 13 at the end of the last video, and then I realized when I was going through the choices that I wasn't explaining it actually perfectly correct. And I have to admit, this is the first problem that, if any of the problems we've seen on the SAT, this is probably the one that's the wording is probably the most difficult to interpret. But I think I figured it out now. So they're saying Kyle's lot combination consists of three two-digit numbers. The combination satisfies the three conditions below. One number is odd. One number is odd. One number is a multiple of 5, so we'll just write that as times 5. And then one number is a day of the month of Kyle's birthday. Day of month of his birthday. And actually, this is what confused me. It actually matters that it's his birthday, not that it's just a day of the month, and I'll show you why. So let's say we have choice A. Choice A. So, and let me color code these conditions. So odd, I'll do it in this blue color. Let me say in times 5. I'll do it in this yellow color. And then let me pick another good color. The brown, the day of the month of his birthday. I'll do it in this brown color. So the first choice, and let me just write these down in a fairly neutral color. I'll do this magenta. So choice A says 14, 20, and 13. So what we can do is, let's see, we have one of the numbers has to be odd, and only one of the numbers, right? So let's say this one. This satisfies the odd condition, and actually only satisfies the odd condition. Then let's see, what number here is times 5, a multiple of 5? Well, this number, let me do it in the yellow. This number is a multiple of 5. And then finally, if that one's a multiple of 5, which one has to be the day of the month of his birthday? What's this choice right here? Now, what confused me when I first did this problem, and probably confused you as well, it says if each number satisfies exactly one of the conditions. Exactly one, right? So that, to me, that means that it can only satisfy one of the conditions. And what confused me was that 20 satisfies a multiple of 5, but to me 20 could just as easily be a day of a month of a day of the month, right? But what the problem that this encounters is here we have to kind of assume that the 14th is his birthday, because if let's put it this way, if the 20th was his birthday, this works if and only if the 14th is his birthday, which it could be. And if the 14th is his birthday, then 20 doesn't satisfy the day of the month of his birthday. It satisfies the day of the month. It wouldn't satisfy the day of the month of his birthday. I know that might seem a little technical, but I think you'll see why I had to make that distinction as you go into choice B. Choice B is, let me do it in that neutral color. It's 14, 25, and 13. So here, once again, 13 satisfies the odd criteria. We could say that 14 will assume that his birthday is the 14th. I mean, we don't know. They haven't told us, but it could be, right? That's what they're asking. What could be the combination of the lock? So we'll say that the 14th could be his birthday. And then if the 14th is his birthday, what does 25 satisfy? Well, 25 now satisfies the odd criterion, and it satisfies the multiple of 5 criterion. So this option, choice B, does not work, because 25 satisfies 2 of the criterion. And I know what you're saying. Well, look, in choice A, doesn't 20 satisfy 2 criterion? Doesn't it satisfy that it could be a day of the month? And what I'm saying is if we assume that the 14th is his birthday, then 20 does not satisfy the day of his birthday, right? We're assuming that the 14th is his birthday. I want you to think that about it. 20th satisfies a potential day of the month, but if we assume his birthday is the 14th, then obviously 20th is not the 14th. And we could go through the other choices. Choice C. Choice C says 15. Now let me do it in a neutral color. 15, 18, 16. And here, well, let's say one of them has to be odd. There's only one odd option here. It's this one. One of them has to be a multiple of 5. Well, there's no multiples of 5 here, so we know that C is not the right answer. D. 20, 15, 20. 20, 15, 20. Well, here we have two of the same numbers, so they're going to satisfy the same criteria. So they're each either going to satisfy two criteria, or they're each going to satisfy none. And they actually both satisfy. There's only one odd one here, so they both have to. One of the 20s have to satisfy the day of the month of his birthday. But then if the day of the month of his birthday is 20th, and then we used the multiple of 5 as being the 20th as well, then both of these numbers satisfy the day of his birthday and a multiple of 5. So that can't be the choice. And then E. Choice E, let me do it in a neutral color again, is 34, 30, 21. And see, 34, it's not odd, it's not a multiple of 5, and it can't be a day of the month of someone's birthday, so that one doesn't work. I think these three are obvious to you why they don't work. Here, the subtlety is that this criteria isn't just a day of the month. The criteria doesn't just say any number between 1 and 31. It has to be the day of the month of his birthday. So we have to kind of pick. We have to say, well, let's assume that his birthday is the 14th. If his birthday is the 14th, then this is the day of the month of his birthday. Then 20 is, of course, not the day of the month of his birthday, so it doesn't satisfy this criterion. It only satisfies times 5. So that's how you have to think about it. And I have to completely admit that I think that this is a little bit of a too nuanced question. Out of the 5 tests we've done so far, this is the first one that I had to take a little bit of off time to figure out on my own. Let's move on to the next problem. Now that we have that one out of the way. All right, problem number 14. Just hope you don't face that when you take the SAT. Square root of x plus 9 is equal to x minus 3. And they say for all values of x greater than 3, so x is greater than 3, the equation above is equivalent to which of the following? So we could do, so x is greater than 3. Let's see where this goes. So let's square both sides of this equation. Let's square both sides just to get rid of the square root sign. So the left-hand side, I'm going to switch colors, becomes x plus 9. And then we just have to multiply that out. So that becomes x squared, x times x, and then minus 6x plus 9, right? You have x times minus 3 is minus 3x, and when you multiply it again, you get minus 3x again. And if you don't remember how to do this, you might want to just multiply out x minus 3 times x minus 3. But going back to this, so this is the relation, and they want us to write it in terms of x. So let's subtract 9 from both sides, and we get x is equal to x squared minus 6x. And that is choice C. And we are done. And the reason why they said x is greater than 3 is because they actually, well, they didn't want you to take the negative square root, right? They wanted you to make sure that this is the positive square root. Next problem. Problem 15. 15. How many integers in the set of all integers from 1 to 100 inclusive are not the square of an integer? So it's 1 to 100 inclusive, so it includes 1 and 100. So what we have to think about is how many squares are there between 1 and 100? Well, 100 is 10 squared. 1 is 1 squared. So every number between 1 and 10 squared is going to be in this range, right? 2 squared. So these are the numbers whose squares 4, 5, 6, 7, 8, 9, 10. And of course, those are 10 numbers, right? So there are 10 numbers. 1 square is 1, 2 squares 4. All of these numbers are going to be between 1 and 100 inclusive. So all of these numbers are there. There's 10 of them. So how many of them are not a perfect square? It's going to be 100 minus 10, minus these 10 numbers. So it's 90, which is choice E. I'll see you in the next video.